Hello and welcome. My name is Varsha Valgapudi. I'm a product manager at Amazon Web Services. And you're in the session COP222. Today I'll be joined by my colleagues, Bala Muttaya, who's a senior developer at Amazon Alexa, and Adel Lalo. He's a senior developer at Amazon Web Services. And today we'll be co-presenting and we'll be talking about removing guesswork when launching new application features. In terms of the agenda, we'll first talk about why validating new application features is so critical. And then we'll talk about the new feature we have for this challenge, which is Amazon CloudWatch Evidently. After that, we will dive into how Amazon Alexa has built their A/B testing feature using Evidently. Finally, we will do a deep dive and a demo and show you how to use the feature. So let me start with a quick audience poll. And I'd like to know how frequent are your release cycles? How many of you release monthly for your features? How many of you do it weekly? And more frequent than that? Daily? OK. That's in line with a survey from Cloud Native. In this survey, they found that 55% of the respondents said that they they release features weekly or faster than that. And we're only seeing that this is getting more faster. As teams are innovating, the releases are getting faster. You want to provide all of the functionality and the goodness to your customers as soon as possible. And when you are releasing them, though, there may be some unintentional consequences. These could be something like unexpected user behavior. You're thinking that a particular feature will improve the experience, but it's causing some other issues. Or it could be something to do with the performance degradation, right, that you might have introduced. And when it comes to managing these launches, we see that developers often implement some manual safety mitigations. These include manually setting up traffic to the new features, which requires additional time. It slows you down overall. In addition, without the visibility into your end user experience, developers often lack enough information to make the decisions of whether or not the feature is the best one for their users. So they commonly generate different variations of new features, use A/B testing to assess the user preference. However, accurately deciphering these results is, again, a challenge. And typically, you require advanced statistical knowledge to be able to do that. And today, customers use multiple different tools. And you also have to then monitor the particular deployment or the feature that you're releasing. So these could be, like I said, the critical metrics that you want to ensure that they're not degrading. So let's look at the tools that we do provide with the Amazon CloudWatch. Firstly, we have the infrastructure monitoring. And customers gain complete visibility of the health of their resources. They can pinpoint outliers with out-of-the-box dashboards. You also have continuous auto-discovery of hosts, containers, logs, events, and more. Then we have application monitoring. Application monitoring focuses on analyzing and optimizing distributed applications at scale. Users of application monitoring can troubleshoot transactions across resources. They can connect monitoring telemetry, such as metrics, logs, traces, and live processes to determine performance bottlenecks. Then we have the digital experience monitoring, which enables customers to connect user interactions to application components. So we have the CloudWatch Synthetics, which acts as a user. And you can have proactive continuous monitoring on your endpoints. So you can connect any APIs or browser test failures to the infrastructure. We introduced 2 new features this week, CloudWatch RUM, which complements the synthetic data with actual client-side telemetry. So you can use CloudWatch RUM to understand your end user experience, including the last mile. So CloudWatch RUM aggregates the data of your application's end user experience across different geolocations, browsers, and devices. Then we have CloudWatch Evidently, which enables customers to validate application choices before launching. So you can then have experimentation and safer launches. Today's session is focused on CloudWatch Evidently. So let's start with what is CloudWatch Evidently. So CloudWatch Evidently is for application developers. You can use Evidently to conduct experiments and identify unintended consequences before you're launching the feature for general use. This allows you to reduce the risk overall. It has two distinct components. One is for experiments. So Evidently helps you remove guesswork when deciding which feature is the best one for your business. Experimental results are presented in a clear way, so you don't need advanced statistical knowledge to interpret them. You're provided with quantitative insights, so you can make data-driven decisions. Then we have the safer launches. When launching new features, developers can expose features to a subset of users, monitor key metrics. Metrics include something like performance metrics, like page load information, or it could be something related to business, like conversions and such. And then safely dial up the traffic for general use. When we're talking about experiments, just like to cover the use cases that we're talking about. So these could be anything like a system experiment where you're testing and validating performance of your code changes at different layers of the stack. These could be product experiments where you're testing new product features, APIs, and UI. So you can design to increase your user engagement. Or these could also be ML experiments where you're testing the algorithms of your ML models. So we talked high level about CloudWatch Evidently and some use cases. Let me show you, or let me talk about how it works. Firstly, you have the application which is being served to your users. You can use CloudWatch Evidently to serve different feature versions or variations to different users. Next, you can collect events and use CloudWatch Evidently to analyze these. So you can basically get monitoring and observability into how individual variation is performing for your users. You can optionally send them to CloudWatch logs for further analysis, or get CloudWatch metrics for alarming notifications. CloudWatch Evidently also has native integration with CloudWatch RUM. So if you're using CloudWatch RUM to collect performance and navigation events, you can use that for your experiments and launches. So let's dive into a little bit more about the experimentation, the user validation that we provide with that. So firstly, we have the easy-to-understand experiment results. And these include statistical results, such as confidence intervals, p-values, and Bayesian inference. And this is near real-time analysis. So what this means is you have anytime valid p-values. So as soon as you reach statistical significance, you can make the decision and move on to launches. So you don't have to wait for like a set period of time to complete an experiment. So this saves you time, basically. And then once you've identified the design of choice, then you can launch that in a controlled fashion. This shows a visualization of an experiment in the console. So you can see that, firstly, at the bottom, the result is shown, like whether or not a particular variation is performing better or worse than the baseline. And you also have the different statistics around that. And you'll be able to see the visualization of the trend of the of the individual variation and the particular metric that is of interest to you. Next, let's talk about the launches feature. So with the safer launches, you can use this feature to limit the exposure of a new feature. So you can limit it to a small audience. Next, you can monitor these key user and performance metrics. And you can safely dial up for general use after this. So if you're finding any anomalies, you can use the optional stop switch. What that does is makes it goes back to a default setting that you have. Then you can dial up or dial down the traffic. You can include any bake time. You can automate. This shows the visualization of launch, where you have two different variations. With the particular metric that we have here is button clicks and how that's performing for the individual variation. And you can automate the dial-up. You can also schedule it in a ramp and ramp it up. I can talk further about the feature, but I think it'll be better if you hear from Alexa on how they have implemented this feature.
Thank you, Ryan. Hello, everyone. Today, I'm going to be talking about how the Amazon Alexa organization was able to use CloudWatch Evidently to do A/B testing and take data-driven launch decisions. First of all, let me quickly introduce myself. My name is Balamurugan Muthaiya, and I'm a senior software developer in the Amazon Alexa organization. I joined Amazon as part of Kindle and later moved to the A/B testing space in the Alexa world. I've been there for 4 years now, helping Alexa developers run A/B tests on different features and identify what are the features that the Alexa customers find most engaging and useful. In 2021, my team partnered with the CloudWatch Evidently team to launch A/B testing for third-party Alexa skills. Let's talk about what an Alexa skill is. Alexa is Amazon's voice-based virtual assistant, and skills are like apps for Alexa. Through skills, Alexa users can do their everyday tasks through voice, such as listening to music, playing a game, or checking for weather. Organizations or individual developers can build, test, and certify their skills using Alexa Skill Store and make it available for millions of Alexa customers. This slide talks about how an Alexa skill works. If you look at the picture, there is an Alexa customer talking to an Alexa-enabled device on step 1. This is a voice request that goes to something called skill interaction model on step 2. This model basically does the skill speech recognition and natural language understanding to know which skill the customer is trying to talk to and what is their intent with that skill. Once a skill and the intent is identified, the request is forwarded to skills application logic, which is also known as the endpoint, which is typically an API or an AWS Lambda endpoint that the developer exposes. This endpoint would understand the intent and then return a corresponding response, which is again a text response, which again goes through the skill interaction model to become a voice response, which is the text-to-speech part, and finally the audio is sent to the device where it gets rendered to the customer. So as you can see, every skill has 2 major parts. One is the interaction model, which contains the machine learning components of it, and the other one is the application logic or endpoint, which actually handles a particular request from a customer. Now, why is A/B testing needed? Before understanding why, let's look at the kind of changes the skill developer wants to make. On the left side, you can see 2 types of interaction model changes. The first one is where the developer can add more sample utterances that represent their skill. This is essential to capture all types of interactions that Alexa customers are having with that skill. So this essentially reduces the friction the customer has with that skill. The second thing they typically do is add a new intent, which is like adding a new capability. For example, if the skill is about booking a cab, now we can also use the same skill to book a movie ticket. And this would, again, increase the customer engagement with the skills. On the right side, you can see different types of application logic experiment where developers can improve upsell messaging. So just like in-app purchases for mobile applications, Alexa Skills has this concept called in-skill purchases, where as a developer, you can offer a premium content or a service for a price. So now the developer wants to know how they can upsell that feature for a price at the right point in time so that they get the best conversion rate. And then lastly, developer can also play around with the response messages that send back to the customer, because this is all voice interaction, so it's essential that the response is as good as possible for the end customers. Now, all of these requires trying out new ideas. No matter how much you believe in your own idea, you will only know how it is useful for the customers after you expose it to them. And this is where A/B testing comes in, because the idea of A/B test is you expose the feature to a small percentage of customers and see how they react. So with A/B testing, third-party skill developers can launch 2 different skill experiences at the same time. For example, if the developer wants to test a shorter upsell message instead of having a longer upsell message, they can have like 2 experiences and split their customers into A and B group and give different experiences. Once they start an A/B test, they can monitor metrics to make sure everything is going smoothly. And at the end of the experiment, they can take a launch decision to whether this feature or this change is actually useful to the customer or not. A/B testing is not only useful for making a launch decision, but you can also learn from your past A/B test. Like, for example, shorter upsell message has better conversion rate, then you can try to do more shorter messages on other things as well. So it's sort of useful for identifying patterns and opportunities of customer behavior with your application, and then expand your scope for whatever you're doing. A/B testing for Alexa Skills is right now available in beta, and this is completely powered by CloudWatch, evidently. So this is a screenshot from the Alexa Developer Console. This is not the AWS console, by the way. And Alexa Developer Console is the place where the Alexa skill developers come to build, test, and certify their skills. As part of the same portal, we built a page for developers to create and manage their A/B tests. So in this page, they can come here and say, hey, this is the name of the test, and this is the hypothesis of the idea that they want to test. And they can also choose the type of experiment. An endpoint experiment is nothing but you can only change the application logic of your skill, whereas a version-based experiment is where you can also change the interaction model of the skill. The next one, which is the traffic exposure, controls what percentage of customers you want to expose into your A/B test, because you don't want to expose all the customer into the test. And you can also specify how long you want to run the test, and the type of metrics you want to measure, and the direction in which you expect the metric to move, whether some metrics, if it goes down, it's actually better, whereas other metrics, if it goes up, it's better. So the direction kind of indicates that. This is another screenshot from the results page of an A/B test. I'm going to take a moment to walk through this page. On the top, you can see the name of the experiment and also the start and end dates of the A/B test. And then you have this table where we show different metrics as rows. So there are 2 metrics right now. One is skill dialogues, which represents the number of interactions that Alexa users are having with the skill. And the second metric is in-skill purchase success rate, which indicates how often customers are buying or purchasing in-skill purchases in your skill. So, and the second column indicates the variations. So you have A and B, or C and T1. C stands for control, and T1 is the first treatment. And the third column is the average value of the metric itself. So in this case, skill dialogues, which is 3.2, is the average number of dialogues your A version of the skill had, whereas the B version of the skill had like 3.5. And the third column indicates, or the fourth column indicates the percentage difference. In this case, is an increase of 9.375%. And the next 2 columns, as Vash has said, are statistics that is used for deciding if this difference observed is statistically significant or not. And the last column simply shows how many users were part of C and T1. So if you look at the numbers here, this is an example of an A/B test report where there was a positive impact in the results, because there is an increase in skill interactions, and there is also a 35% increase in in-skill purchase success rate. Next, I'm going to talk about the underlying architecture on how this works and how it is using CloudWatch, evidently. On the left side, you have the Alexa skill developer, and they're coming to the Alexa developer console to manage their A/B tests. And whenever they try to create or start or stop an experiment, it actually calls the evidently APIs for managing the experiments. As part of the same developer console, the skill developer would set up both the A and B versions of their skill. On the right side, you have millions of Alexa customers talking to Alexa-enabled device, which eventually comes to this Alexa skill request handler, and it decides which skill to call. And then it also makes a call to evidently to know the assignment for that customer, because you need to know whether the customer should be part of the A group or the B group. Once it evidently returns that assignment, the handler would invoke the corresponding version of the skill. As part of this get assignment call, we also log that event into evidently, because we want to know when a customer entered into a particular experiment at what point in time. On the center, we consume both the assignment data and the analytics results from the CloudWatch evidently, which they make it available both in CloudWatch logs and S3 bucket. And then we run it through our own analytics and generate a final report and publish it back to the developer console, which is the slide that you saw before. So as you can see on the left side, we have not just one developer, but hundreds or even thousands of skilled developers trying to run A/B tests. And on the right side, you have millions or tens of millions of Alexa customers trying to talk to Alexa. So everything is sort of used on both places to be able to manage the lifecycle of the experiment and also assign customers to both A and B version of the skill. In this last slide, I'm going to talk about why we chose to use Evidently. First of all, we wanted to build an integrated experience in the Alexa developer console. And Evidently offered all the APIs that we need, such as create, start, and stop experiments, and also gradually dial up traffic. Because as you run the experiment, you might realize that there is not enough customers in it, so you can gradually increase more customers into the A/B test. It also offers this capability of adding overrides into an experiment, and overrides are a way where you can force a particular user of your skill into an A or B group and then use it for testing. And this is useful because the skill developer wants to validate their setup of both A and B version before they can actually start an A/B test. The second reason why we chose to use Evidently is because the results and the assignment data is available within a few minutes. And this is essential because as soon as you start an A/B test, you should be able to know whether it's actually doing any harm to the end customers. So it's essential that you look at the results as soon as possible, and if something is wrong, you shut down the experiment. The third reason, as I was showing in the previous slide, is that we want to scale to tens of millions of customers. And also from the developer perspective, at any point in time, we can have hundreds of skilled developers running experiments in parallel. And the last thing is we also wanted to expand to internal Alexa use cases, such as improving the core capability of Alexa through A/B testing. And this is where we also started using Evidently to run A/B tests to identify what are the best features of Alexa, and that is the customers are finding it most useful. So that brings me to the end of my presentation. So to summarize, Amazon Alexa as an organization was able to use CloudWatch Evidently to do large-scale A/B testing. And we actually learned a lot from some of the results, which are sometimes surprising because we had some of the developers reach out to us and say, hey, they had a really great idea and they tried to do an A/B test, and then they saw the results and it's actually in the opposite direction of what they expected. So we had a lot of learnings from these A/B tests, and we are able to scale for hundreds of developers right now. Thank you.
All right. Thanks, Bala. Hello. I am Adel Lalu, a software developer on CloudWatch Evidently. Great. A little bit about myself. I've been working in experimentation and feature management at AWS for several years now. I've worked with Alexa and other customers in payments, blogging and multimedia, and e-commerce to instrument CloudWatch Evidently in their web applications, their APIs, and their backends. I'm excited to be here today. I'm going to visualize a lot of the features you heard about from Bala and Varsha. We're going to set up an experiment in an application in about the next 15 minutes. So an overview for this deep dive. First, I'm going to introduce the application we'll be working with to get you familiar, and we're going to set a couple goals for the experiment we're going to set up today. Next, I'm going to give you an overview of a completed experiment in the Evidently console so you can see what value and what results you'll be getting when you run an experiment through Evidently. Last, we'll set one up from scratch and show you the process of how to set up a feature and set up an experiment and what kind of decisions you can make to customize for your use case. So this is our application. We are builders building a bookstore on AWS. I know, it's a very novel idea, all puns intended. A web app homepage is extremely valuable. Setting up a homepage with the right assets, messaging, and navigation will help your customers find what they're looking for faster, easier, and engage them and drive your business and conversions. But sometimes when you make a change to a homepage, it can have far-reaching effects that you don't expect. So it makes a perfect place to set up experiments and safe launches with CloudWatch Evidently. We'll look at a couple features today on this homepage. The first feature we'll look at is the homepage promotion banner. This is an ideal feature to power with CloudWatch Evidently. It's something that changes frequently, is self-contained, and is something you can't really test until you put it out in production and see how your customers respond to it. Today, we're going to set up an experiment from scratch where we compare two different promotions to see which one performs better and which one will increase our revenue the most. Another feature we're going to look at is highlighted categories. Highlighted categories are very similar to promotions. They can change with seasons, holidays, and events, or be personalized for your customers. We'll review a completed experiment where we compared two different sets of categories, one with seasonal categories and one with top-selling categories, to see which one performed the best in terms of revenues and click interaction. Now, these are two visual features, but you're not limited to only visual features. For example, you could do an experiment or launch on your product search ranking. For example, if you're making significant changes to how you do product search, you can do a safe launch to ensure that you're still getting your customers to find what they're looking for. For today, we're going to stick to the visual features. All right, now I will just hop over into the AWS console. Okay. Great. Okay, you can find Evidently in the CloudWatch console on the left side nav under Application Monitoring. You'll see a few other digital experience monitoring services that were mentioned earlier, including Synthetics and RUM. If you're planning to use CloudWatch Evidently in your web application to optimize your user experience, I encourage you to check out RUM, which will also help you monitor your web application performance as well as your user experience there. We'll have more details on the RUM session at the end of this talk. Heading back to Evidently, when you first open up Evidently, you'll see a list of projects. Projects are your top-level container resource for Evidently that will contain your features, launches, and experiments. We recommend that you make one project per application to simplify your security, your IAM permissions, and keep everything organized together. When you go into a bookstore, you'll see that you have 3 more resources available. Usually when you're starting off with Evidently, the very first thing you'll do is create a feature. You'll see here that we already have a feature named Highlighted Categories. We'll go a little bit more into how to make a feature in a few moments. But first, I just want to show that after you've created a feature, you can start creating launches and experiments. We're going to hop over to Experiments and open up a completed experiment. First thing we'll do is hop over to the configuration and talk about what this experiment was trying to accomplish. You'll see here that we have 2 variations. One is a set of summer categories, and another is a set of top-selling categories. And you'll see that that our hypothesis was that treating the top-selling categories as our default, our baseline, that we hypothesized that both the summer set of categories will increase our revenue as well as increase our click interaction with our categories. So setting up the experiment is as simple as choosing these 2 categories. Now let's see how our hypothesis did in this experiment. Well, I think get a reload here. Great. So you'll see that you have a set of the metrics you selected for this experiment, as well as a few of the statistics available here. When you graph this, you'll see that the metrics you chose for the experiment are broken down by variation. So as you run the experiment, Evidently will automatically correlate which of your users saw which variation and make sure to attribute the right data points to the right variation. From this graph, you can see pretty clearly that our hypothesis was wrong, that summer categories consistently performed worse than the top-selling categories. You'll see a lot of the results that Bala alluded to on the Alexa console here in the Evidently console as well. In addition to the usual statistics like event counts and average, you'll see the additional insights that was mentioned by Varsha, including statistical significance based on anytime p-values, as well as improvement based on 95% confidence intervals. You can also see a short summary for each treatment that's in this experiment in the result column here, where we state, according to popular convention, how that treatment performed. At this point, you're probably like, okay, I see the experiment, I've seen the results in both the Alexa and on this example, how do we set one up? So we'll hop back into the project and we'll start by adding a feature. We'll call this feature the promotional banner. In Evidently, you can represent a feature with a value. It can be a Boolean type, a long, a double, or a string. In this case, we're going to choose a string, and we're going to use image URLs to represent our promotion banner. So we'll start off with the default of an empty banner, meaning that we will have our default will be to not show customers any type of banner. And we'll just leave this one empty for now. We'll set up two more variations that we're going to test against each other. One will be a buy one, get one, 20% off or 25% off, as well as another where we give a flat 20% off. I'm going to quickly copy over these URLs. Into the variations. And now I've set up 3 different variations. One empty one, which will be the default, so none of our customers will see any promotion banners, as well as 2 different promotions we plan to test in an experiment. In this sample code dropdown, you'll see a code snippet that you can copy and paste into your application. So when you set up a feature in Evidently, you can take this snippet, copy and paste it into your application where you want to use this value and to help drive your application logic. We'll go ahead and finish adding this feature. Great. So I'm going to jump over to our application now. This is our bookstore. And one note I want to make is that I am using an override here in the URL to switch between different accounts so that I don't have to log in and out. You can see that there's no promotion banner right now. And so I want to make sure that the promotion banners that I've set up in Evidently are working. So I'm going to head back to the Evidently console. And on this screen, I'll see the list of evaluation rules that are making the decision on what variation to show my customer. I'm going to go to overrides, and I'm going to add my development account, an override for my development account. I add one for Adele. I'm going to set it to the buy one, get one variation. And then I'm going to hop over to the bookstore. I'm just going to hit reload. And pretty quickly, I get instant confirmation that I've set up my variation correctly. I can see my promotion banner is working. I read through the banner, and it looks right to me. I'm going to go back and make sure that the other variation is working as well. Okay, I seem to have put in the wrong promotion here. So I'm just going to really quickly fix that. Okay, all right. I took care of that, and both of these variations look good to me. One thing I just want to show you is to show that this is only available on my developer account. I'm going to go ahead and log in as Varsha here, and we can confirm that none of the other customers are seeing any promotion banners at this time. Let's change that. Let's hop over, and let's start our experiment. So when you're creating an experiment, you get to select from a list of existing features. So we're going to go ahead and select the promotional banner. And we can see the list of variations that we have available to experiment with. Like you saw earlier in the Alexa console, you get to choose how much of your traffic, web application traffic, you want to expose to this experiment. In this case, we're going to leave it at 100%. You can also choose which variations you want to include in this experiment. Where you're going to exclude the empty one, we want to make sure all our customers get some type of promotion in this case. And we'll be comparing the buy one, get one, and the 20% off. When you come down to metrics, you're able to either instrument with run metrics if you have them available, or set up a custom metric. In this case, we're going to do revenue. And when you set up a metric, you have to choose an entity ID. This is what we're going to use to correlate which users saw which variation with the metric data points you send us. So in this case, we're going to choose session ID. and we're going to look for the revenue key value. And there are additional event patterns that you can add as filters, and you can check out how to define those in our documentation. So we've chosen our variations. We've set up the traffic split between the two variations and set up the revenue metric to track during this experiment. We'll go ahead and create this experiment. Okay, great. So the experiment's created now. All we've got to do now is start it, and then we can hop back into the application to see what our customers are seeing. When you start an experiment, you can select our duration to plan out how long you want the experiment to run for. We're just going to keep the default 1 week. Great, we can see that this experiment is live now. We're going to hop back in this application. I'm logged in as Varsha. Let's see what Varsha gets. All right, Varsha is getting 25 buy one, get one off, 25%. I hope Varsha enjoys that promotion. And let's check what Bala is getting. Bala, you are actually also getting 25% off. And so you can start to see that we're already exposing our customers to this experiment. So as this experiment runs, the experiment details and results page will be populated within minutes with results. Once you've ran the experiments long enough and looked at the results and have made a decision to launch, you can come back to the Evidently console and create a launch, and start a launch on that feature once you've made a decision. So we'll go back here and we'll choose the promotional banner again and configure our launch in a very similar way to we configured our experiment. One unique thing with launches is that you can create a schedule for this launch. So for example, we can start off today with the same percentage that we had in the experiment. We can start it off at 50-50. Let's say that we want to gently ramp that up over time to, let's say, 100% for our 20% off, which ended up being our winner for the experiment. You can come back here, set up a set of steps to gradually dial up that traffic to 100%. All right. And with that, I'm going to hop back into the slide deck. Oops. Do you mind if I get that? Okay, great. So just a quick recap of what we just did. The first thing we did was review Evidently projects and concepts. The next thing we did was we created a promotion feature, and when we set up that feature, we set up different variations. We used overrides to preview those variations to make sure we had set them up correctly. We created a promotion experiment and saw that we could see our customers start to be allocated to different variations so that we can start receiving experiment results. We also reviewed a complete experiment where we looked at evaluations and the results about highlighted categories. And that concludes the end of this walkthrough, and I'm going to turn it back over to Varsha for our closing.
Thank you, Odell. That was quite detailed and very informative. Just would like to recap the session. So today we talked first about the challenges when you have to innovate and release new features and updates. Next, we talked about CloudWatch Evidently and how this can help you with safer launches and experimentation. After that, we heard from Bala for the A/B testing feature with Amazon Alexa for the skilled developers. I thought that was really cool. Then finally, we saw the Evidently in demo and saw how to set up an experiment. Also would like to highlight some observability sessions that are going on right now. for other sessions that might be of interest. The one session that we did talk about today, the CloudWatch RUM, that's tomorrow. So if you're interested, you can go check that out. There's also some resources that we have. We have a news blog out there that talks about CloudWatch Evidently and details out some of the things that we talked about today. There's also an observability workshop that you can get hands-on experience for all AWS observability features. And for the pricing, we have the pricing information on the CloudWatch pricing page. With that, I'd like to thank you for your time today. We hope you will be able to try it out and give us some feedback. Thank you.